Hello students, welcome back to my channel JPPHYSICS. Up to last lectures, we have discussed the important derivations from rotational dynamics. From today's lecture, we will discuss important derivations from mechanical properties of fluid. In this first, I am going to discuss molecular theory of surface tension. It is also called as Laplace's molecular theory of surface tension. Actually, it is not a derivation. It is a theoretical question, but some mistakes get done by the students and that must be avoided in this theoretical question. So I have taken this question, that is explain Laplace's molecular theory of surface tension, or simply explain the molecular theory of surface tension. This question will be for 3 marks. So let us discuss about this theoretical question. For this derivation, we have to consider one container which contains liquid, right one? And in this liquid, let us consider that liquid is as a water. We can consider water also. Here we have to discuss, or we have to consider, 3 molecules from this liquid or from this water. So I will take one molecule as A, and sphere of influence of this molecule is totally inside the liquid. Here the student make the mistake. See, I have considered molecule A. This is molecule. हा molecule आहे. आणि हा जो ड्रॉ केलाय तो sphere of influence आहे. See, this center dot is showing molecule A. This is not the molecule. This dot is the molecule A, and this is the sphere of influence, that is sphere drawn around the molecule, in which if another molecule comes, it will experience as a force. Maybe that will be cohesive force, maybe that will be adhesive force. Right one? What I am saying, this molecule is molecule A, and this sphere drawn around that molecule, it is a sphere of influence. हा जो स्पियर याच्या भोवती जो ड्रॉ केलेला आहे त्याला स्पियर ऑफ इन्फ्लुएन्स म्हणतात. हा मोलिक्यूल ए आहे. हा पुरा मोलिक्यूल ए नाही आहे, हा मोलिक्यूल ए आहे आणि त्याच्या भोवती जो स्पियर ड्रॉ केलेला आहे तो स्पियर ऑफ इन्फ्लुएन्स आहे. ओके, इट इज नॉट अ मोलिक्यूल. दिस टोटल पार्ट इज नॉट अ मोलिक्यूल. दिस डॉट इज ओनली मोलिक्यूल. Okay, so now here there will be only one type of force will act on that molecule here. See, this molecule A and its sphere of influence is totally inside the liquid or fluid, you can say, or you can say water. If we have to understand this, you can consider this is water and we are considering the molecules of water, or simply you can say we are going to consider one fluid or liquid and this A is one molecule of that liquid. Okay, and this sphere is sphere of influence, and this arrow are showing the force acting on this molecule by the another molecules of same liquid. And we know that the force of attraction between the molecules of same substance, it is called as a cohesive force. There are 2 types of force, cohesive force and adhesive force. The force of attraction between the molecules of same substance, it is cohesive force, and this sphere of influence of molecule A is totally inside the liquid, so that only cohesive force will act on this molecule A. What I am saying, see, this molecule is only attracted by the molecule of water only. There is no any another substance, no any another liquid. कुठल्याही दुसऱ्या प्रकारच्या मोलिक्युल्स मुळे याच्यावर फोर्स ऍक्ट होत नाहीये. फक्त फोर्स कुणामुळे ऍक्ट होतोय? वॉटर मोलिक्युल्स मुळे किंवा त्यात सेम लिक्विड मुळे. हे जे काही लिक्विड आपण कन्सिडर केलेलं असेल, या लिक्विड मुळे फक्त याच्यावर काय होतोय? फोर्स ऑफ अट्रॅक्शन अप्लाय होतो या मोलिक्यूल ए वर. तो फोर्स आपण कसा दाखवणार आहे? बाय दिस एरो. सी, ऑल these forces. Okay, molecules will attract this molecule towards this side, also towards this side, towards this side, also towards this side, upper side, lower side, right side, left side. Means from all sides this molecule A will get attracted. So what happened? All these forces will get cancelled. all these forces will get cancelled. Upper, lower, left, right, all these forces will get cancelled with each other, and resultant cohesive force acting on this molecule A will be 0. Means when you are going to write this theory, you are going to write first, we have to consider here 3 molecules, that is molecule A, B and C. Then for molecule A, you will write first for molecule A, sphere of influence will be totally inside the liquid. This part is very important when you are writing. See, sphere of influence of the molecule, not the molecule. मुलं काय करतात, molecule A हा पूर्ण लिक्विड मध्ये आहे असं म्हणतात. That is, molecule A is totally inside the liquid. That molecule is of that same liquid. It will be inside the liquid. It is not going to outside. But its sphere of influence can be outside the liquid. Right one? You are going to understand what I am saying. Don't say molecule A inside the liquid. Say sphere of influence of molecule A is totally inside the liquid. Don't make mistake here. Sphere of influence of molecule A is totally inside the liquid. So that molecule A will get attracted from all the sides, and therefore the resultant cohesive force acting on this molecule will be 0. That is resultant cohesive force. Resultant cohesive force acting on molecule A is equal to 0. Resultant cohesive force जो ऍक्ट होणार आहे molecule A वर तो पूर्ण काय असणार आहे 0. Net cohesive force, that is resultant cohesive force acting on molecule A is equal to 0. Now we have to consider another molecule B, which has sphere of influence, that is small part of that sphere of influence will be outside the liquid and bigger part will be inside the liquid. Means if I consider molecule B at this point, this is molecule B, then its small part of sphere of influence will be outside the liquid and bigger part will be inside the liquid, like this. Bigger part will be inside the liquid and small part, only this small part will be outside the liquid. Let us consider this as a molecule B. Molecule B कसा आहे, त्याचा स्पियर ऑफ इन्फ्लुएन्स, त्याचा छोटासा पार्ट, स्मॉल पार्ट ऑफ स्पियर ऑफ इन्फ्लुएन्स विल बी आउटसाइड द लिक्विड, नॉट द molecule B. See, molecule B is of the same liquid, right one? Its sphere of influence, small part of its sphere of influence will be outside the liquid and bigger part will be inside the liquid. जिथं मी ह्या लाईन ड्रॉ केलेला आहे तो सगळा पार्ट स्पियर ऑफ इन्फ्लुएन्सचा लिक्विड मध्ये आहे आणि हा जो ब्लँक पार्ट दाखवलेला आहे तो पार्ट फक्त कुठे आहे, आउटसाइड द लिक्विड आहे, राईट वन. नाउ इफ वी कन्सिडर द फोर्सेस ऍक्टिंग ऑन मोलिक्यूल बी, that forces will be of two types. One, it will be cohesive due to this water molecule present in this bigger part of sphere of influence, and small part which is outside the liquid, there will be air molecules. Here there will be air molecules, right one. Now what will be the resultant force acting on this molecule B? See, number of molecules which are present in this sphere of influence, bigger part of sphere of influence will be water molecules, right one, or the molecules of that same liquid. But these molecules which are present in this upper part, small part which is outside the liquid will be less in number. So that molecule also attracts that molecule B. एक लक्षात घ्या, हा जो वरचा छोटासा पार्ट आहे स्पियर ऑफ इन्फ्लुएन्सचा त्याच्यात एअर मोलिक्युल्स असणार आहेत, बरोबर, आणि हा जो मोठा पार्ट आहे स्पियर ऑफ इन्फ्लुएन्सचा तो आतमध्ये असणार आहे लिक्विड मध्ये. म्हणजे लिक्विडमध्ये असलेले जे काही मोलिक्युल्स आहेत त्यांची संख्या जास्त आहे कंपेअर टू दिस मोलिक्युल्स इन upper part, small part of that sphere of influence. So they will exert adhesive force, attractive adhesive force on this molecule B, and also the water molecules or these molecules of this same liquid will exert cohesive force on molecule B. मोलिक्युल बी वर दोन प्रकारचे फोर्सेस ऍक्ट होणार, ऍडेसिव्ह आणि कोहेसिव्ह. कोहेसिव्ह फोर्स कुणामुळे असणार? ड्यू टू सेम लिक्विड. Force exerted by same molecules or the molecules of same liquid, and the force exerted, adhesive force will be exerted on that molecule B due to the air molecules, and that number is less. Therefore resultant downward cohesive force will act on this molecule B. Why? See, here there will be water molecules, here there will be water molecules. They will attract or pull this molecule towards right, this molecule towards left. They will get cancelled. But when we consider upper and lower part, these molecules will be large in number. They will attract this molecule and they will exert the greater cohesive force on this molecule B, which will be in downward direction. And small amount of adhesive force will act in upward direction due to this air molecules. ऍडेसिव्ह फोर्सची जी व्हॅल्यू असणार आहे ती कम्पेअर टू कोहेसिव्ह फोर्स काय असणार आहे? कमी असणार आहे, लेस असणार आहे. सो हिअर द रिझल्टंट फोर्स ऑर नेट फोर्स विल बी कोहेसिव्ह फोर्स अँड दॅट फोर्स विल बी इन डाउनवर्ड डिरेक्शन. मीन्स फॉर मोलिक्यूल बी sphere of influence, small part of sphere of influence, small part of sphere of influence will be outside the liquid, right? Therefore net force, or you can say resultant cohesive force will act on molecule B in downward direction. You understood? Resultant or net downward cohesive force will acting on molecule B. Now we will consider molecule C. That molecule C having half sphere of influence outside the liquid and half sphere of influence inside the liquid. So this will be the sphere of influence. This molecule is C, and here half part of sphere of influence will be outside the liquid and half part will be inside the liquid. Now in this case, what will be the resultant or net force acting on molecule C? See, half part of sphere of influence outside the liquid, but it contains air molecules. That air molecules exert adhesive force on this molecule C, and the molecules which are present inside the liquid and in that sphere of influence, half part of sphere of influence, will act on this molecule C, and the resultant will be, some students will think that half part is outside, half part is inside, means that will get balance and no force will act on this molecule C, but not the case. See what happens, this liquid having higher density compared to this air, right one? This liquid having higher density than this air molecule or this air section, means here the number of molecules of this same liquid will be greater in number compared to this half part of sphere of influence. जितके एअर मॉलिक्युल्स या हाफ पार्ट मध्ये असतील त्याच्या कंपॅरिझन मध्ये ह्या राहिलेल्या हाफ पार्ट मध्ये जास्त नंबर असणार आहे वॉटर मॉलिक्युल्सचा किंवा त्या लिक्विडच्या मॉलिक्युल्सचा. म्हणजे जर समजा आपण असं कन्सिडर केलं, फॉर एक्झाम्पल, इफ देर आर 10 molecules of air 10 molecules of air. In this half part of sphere of influence which is inside the liquid, there will be maybe 30 water molecules or maybe 20 water molecules, but definitely greater than this air molecules. Why? Because density of air will be less compared to this water or that liquid. जी डेन्सिटी असणार आहे लिक्विडची ती नक्कीच या एअर पेक्षा काय असणार आहे, जास्त असणार आहे. म्हणजे इथं जी वॉटर मॉलिक्युल्सची संख्या असणार आहे निम्म्या भागामध्ये, या निम्म्या स्पिअर ऑफ इन्फ्लुएन्स मध्ये ती जास्त असणार आहे. कुणाच्या कंपॅरिझन मध्ये? या हाफ पार्टच्या कंपॅरिझन मध्ये. म्हणजे जो याच्यावर रिझल्टंट फोर्स ऍक्ट होणार आहे तो आत्ता सुद्धा काय असणार आहे, हो डाऊनवर्ड असणार आहे. That means here adhesive force will be less than cohesive force. Means here greater force or resultant net cohesive force is acting in again downward direction. म्हणजे या C मोलिक्यूल वर सुद्धा जो नेट कोहेसिव्ह फोर्स, मुळात नेट कोहेसिव्ह फोर्सच ऍक्ट होणार, ऍडेसिव्ह फोर्स कॅन्सल होणार. ऍडेसिव्ह फोर्सच्या कंपॅरिझन मध्ये तुमचा कोहेसिव्ह फोर्स जो डाऊनवर्ड डिरेक्शनला आहे तो जास्त असणार आहे. Therefore, the resultant downward cohesive force will act on this molecule C. Means for molecule C, what will be the result? Molecule C. See, half part of sphere of influence, half part of sphere of influence will be outside the liquid and half part will be inside the liquid. Half part of sphere of influence, not the half part of molecule C. Half part of influence of molecule C will be outside the liquid and half part will be inside the liquid, and net less cohesive, net less downward cohesive force act on C, molecule C. Okay, so these are the important things you have to write about the explanation of molecule A, molecule B and molecule C. These things must be come in your explanation, must be. And don't write half part of molecule A or small part of molecule B. Don't write like this. Okay, because half part of sphere of influence, small part of sphere of influence and whole sphere of influence is inside the liquid. So don't write like this, half part of molecule A, half part of molecule C. You have to write half part of sphere of influence, small part of sphere of influence and whole sphere of influence of molecule A is inside the liquid. So during writing the explanation, these things you have to keep in your mind. Okay, so this is the explanation for molecular theory. Then what happens if these forces, net cohesive forces, are acting on this two molecule, that is molecule B and molecule C? Here that cohesive force will be greater compared to cohesive force, downward cohesive force acting on molecule C, but both are in downward direction. Net cohesive force is acting in downward direction. Then what happens? Due to this, number of molecules present in that surface film, means in this region, which is equal to the radius or molecular range. In that region, molecules will be less in number and that liquid will act as a stretched membrane. That is, it act like somewhat pulling it downward. Means it is acting like it is under tension. So due to this downward cohesive force, this liquid at the surface will act like it is under tension. अंडर टेन्शन असल्यासारखं लिक्विड ऍक्ट होतं. सगळा जो फोर्स त्याच्यावर ऍक्ट होणार आहे तो डाऊनवर्ड डिरेक्शनला असणार आहे, राईट. मग तो जो डाऊनवर्ड डिरेक्शनचा फोर्स आहे ते लिक्विडला काय केलं ना, पुल केल्यासारखं ऍक्ट होणार आहे, खाली खेचलं जाणार आहे लिक्विड. म्हणजे तो सरफेस अंडर टेन्शन असल्यासारखा बिहेव करतो. आणि हीच सरफेस टेन्शनची डेफिनेशन आहे. सरफेस टेन्शन इज द प्रॉपर्टी ऑफ द fluid or property of the liquid due to which it acts such that it is under tension, or it acts such that like a stretched membrane. That is, surface tension is the property of the liquid due to which it acts as a stretched membrane. It is called as a surface tension. So this is the explanation for molecular theory. When you are writing the explanation, you have to mention these things prominently in your explanation. That is, for molecule A, whole sphere of influence of molecule A totally inside the liquid, small part of sphere of influence of B outside the liquid, and half part of a sphere of influence of C inside the liquid and half part outside the liquid. Sphere of influence, not molecule A, B, C is present totally inside the liquid. Small part of molecule B totally outside the liquid. Remember this thing prominently, that you have to write the small part, half part, and total sphere of influence present inside the liquid. You understood this derivation or this explanation of molecular theory of surface tension. They can ask Laplace's molecular theory also. So you have to write this explanation. If you want the screenshot, you can take it. Okay. So in next lecture, we will do that derivation for surface energy, pressure, and all things. If you like my explanation, like this video, share, like, and subscribe it. Also press the bell icon so that you will get the notification for next lecture, and do watching. Thank you.